Welcome to Module 3 Video 4 using Web3.js to interact with Ethereum. In this video, we will dive deep into the Web3.js library, which is popular JavaScript API for interacting with the Ethereum blockchain. By the end of this session, you will be able to understand the essential functions and features of Web3.js and how to use them in your decentralized application. Web3.js acts as a bridge between JavaScript applications and the Ethereum blockchain. It allows developers to create web applications that can read and write data to the blockchain, manage user account, and interact with smart contracts seamlessly. It will cover these key points. First, we'll have the introduction to Web3.js, then we'll learn how to set up the development environment for Web3.js, and then we will connect it to an Ethereum node. Let's move forward. Web3.js is a JavaScript library that allows developers to interact with the Ethereum blockchain. It provides functions for reading and writing data to the blockchain, managing accounts, and interacting with smart contracts. Think of Web3.js as a remote control that lets you operate various functions of smart TV, where the TV represents the Ethereum blockchain. Web3.js abstracts the complexities of blockchain interactions and provides a simple API for developers. It supports synchronous and asynchronous calls, making it versatile for different use cases. In Web3.js, you can connect to different types of Ethereum nodes such as local nodes, remote nodes, and even hosted solutions like Infura. This flexibility is crucial for developers working in various environments. Setting up your development environment is like preparing a workshop with all necessary tools and materials. Here are the steps. First of all, install node.js and npm. I hope you have already installed these for previous project. If you have not, you can install these from nodejs.org. Now create a new project directory. Navigate to a desired location and create a new directory using mkdir and then your project name. Then inside this project, run npm init to create package.json file. Then we will install web3.js by using npm install web3. This will install the web3.js library in your directory. Connecting to a mini Ethereum node using Web3.js is essential for interacting with the blockchain. This can be done using local node, an Infura node, or another Ethereum node provider. It's like connecting your remote control to the smart TV to enable interaction. Here's the code for local Ethereum node. The first three lines show the code for local Ethereum node, and then later it is for an Infura node. If you see these lines import the Web3 library, making its function available in your script, and the next line creates a local host. And the URL you see in the bottom is for the Infura node. It specifies the URL of the Infura node along with your project ID. Interacting with smart contracts involve creating contract instances using the contracts ABI, application binary interface, and address. It's like using the remote control to access different apps and functions on the smart TV. You can see the example code. I'll explain this code to you. The first line is the ABI is a JSON array that describes the contract's functions and events. Then the next line is an Ethereum address where the contract is deployed. And the next line creates an instance of contract allowing you to call its function. Then we call a function in which an asynchronous function is to call the getMessage method of the contract. Then the next line calls the getMessage function and waits for the result. And the console.log line logs the message to the console. Then we make a function for sending a transaction, the asynchronous function to send a transaction. It retrieves a list of account, sends a transaction to set a new message from the first account. Managing Ethereum accounts using Web3.js includes retrieving account balances and creating new accounts. It's similar to managing user profile on Smart TV. Here is the code. This code contains two asynchronous functions, one to get account balance and another to create a new account. The first asynchronous function, which gets the account balance, retrieves a list of all variable accounts. Then it gets the balance of the first account in V. V is spelled as WEI. It is having the value 10 power minus 18 Ethereum. So it gets the balance of the first account in V, converts the balance from V to Ether and logs it. The second function, which creates a new account, uses console.log, logs the new account's address, and the next line logs the new account's private key. Sending transaction using Web3.js allows you to transfer Ether or interact with smart contracts. This process is akin to using the remote control to make in-app purchases or change settings on the smart TV. Here is the code. In this code contains a asynchronous function which is used for sending transactions. The second line retrieves a list of all available accounts. The third line sends a transaction and waits for the receipt. Next line specifies the sender's address. The next line specifies the receiver address, and the next line specifies the amount to send converted from Ether to V. The console.log lines logs the transaction receipt, which contains detail about the transaction. Listening for events emitted by smart contracts using Web3.js helps us receive notification of certain actions or state changes. It's like setting up notifications on your smart TV to alert you when certain actions occur. You can see the code. The code listens for the message updated event emitted by the contract. Error comma event is a callback function that handles the event or error. Then the code has if function. If there is no error, then the console.log logs the new message from the event's return values. Else it shows an error and it looks error from the console. Using Web3.js in a D app is like using the remote control to interact with various features and functions on a smart TV. This comprehensive example demonstrates how to use Web3.js to interact with an Ethereum smart contract, manage accounts, send transactions, and listen for events. This D app, this D app with Web3.js includes the functionalities of connecting to MetaMask account, getting and setting message, and getting the account balance. Let's see the code. So this is the complete example of our code. It has basic HTML, CSS and JavaScript. These HTML lines are pretty basic, which defines the title, the head and the headings of the front end, and it also has buttons. And then the script contains the URL, which includes the web3.js, and the let web3 and let account defines the variable for web3 and the MetaMask account. Here we are basically combining all the codes we have studied till now. This is the code of connecting to MetaMask. We saw in the last lecture how to write this code and what the lines of this code mean. If you are not sure about that, you can watch that video. So here basically we connect the MetaMask account through this code, a synchronized function, and then on the next slide, these functions we just studied in this slide only. So combining all these codes will make the complete example of our code. Thank you for watching this video on using Web3.js to interact with the Ethereum blockchain. We have covered the essentials from setting up your environment, connecting to an Ethereum node, interacting with smart contracts, managing accounts, sending transactions, and listening for events. Understanding these concepts and practice will empower you to build robust and interactive decentralized applications. Finally, I'll ask you to go through all the codes of this video and do this project on your own so that you get a better grip on what we are doing. So as an exercise, you can do all this project on your own on your laptop. Thank you.